This is the video for section P3 on polynomials. We're going to start with a quick review of polynomials as they're classified by number of terms and degree, something that we've seen both in Algebra 1 and in Algebra 2. Number of terms, we have some terms that refer to how many terms are in the polynomial. Polynomials separated by sum and difference of terms, and the keywords here that we're looking for are monomial, a binomial, and a trinomial. And the prefixes go along with those terms. A monomial has one term. A binomial has two terms. And the trinomial has three terms. And we don't have any special names for the polynomials that go up in size. Degree has to do with the powers of the terms. Each term itself can have a degree. So in order to get the degree of a term, we need to examine that individual term and sum up the powers in the term. Sum up the powers of the variables. So we're using the first 10 problems that you see in your assignment sheet for day 4 to kind of talk about this in review. Alright, so a monomial of degree 2 has to have a single term, and the sum of the powers of each of those variables has to go to 2. So if we take a look at the 3 possible numbers we could answer here, G has one term, D has one term, and J has one term. Right? And of those 3, D is the only one that has variables. And you notice that each of those variables are to the first power. We add them up, and they make 2. Right? So number 1 matches with D. And we could call that a monomial of degree 2. And that also refers, the degree 2 also refers to the word quadratic. Something that we're very familiar with and have already worked with this year. Alright, taking a look at the second one, we're looking at a binomial, which has 2 terms and a degree 3. So now if we take a look at the polynomials that have 2 terms, that could be A, that could be E, and what else? And it could be F. Alright, degree 3, well, if we check out A, the first term here, and we're looking at those powers, and they sum up to 4. And the other one here, the power is of a 3, and a number F, that term has a degree 2. Right? Now in A, we have another term, and that's also has its own degree, and that's 2. But the degree of the polynomial is the higher of those 2 degrees. So the one that we're looking for here in number 2 is going to be part E, the 2 terms with a degree of 3. So that's going to be E. And degree 3 also comes back and refers to the word cubic. So we can be referring to the degree of the polynomial either by a number or by the words, other words that refer to certain types of degrees. Alright. When they talk about number 3, a polynomial, they're not giving any specific number of terms, so for the most part that usually goes to something that has more than 3 terms, because we don't have special terms after that. But what we're looking at in part E is that this is going to have a degree of 5. So as we come through and check out all of the other polynomials that are remaining, in number C, the largest degrees I have are just going to be degree 2, so it can't be that one. In part I, that has a degree 4. In B, that has a degree 2. So the only thing I've got here is going along with H based on the highest power in that polynomial. So that would be answering there in H. All right. Some other terms that we should be familiar with: leading coefficient. That means you're looking at the highest power in that polynomial, and it's the number multiplying the variable expression. And because we have binomial, we're going back and we're looking at those two-term polynomials that we did at first. And checking back there, that would lead us to F. We've got the two terms in F, and we've got the lead coefficient. Even though it's not first, it does have the power with it. So that would be the term with the highest power. So we have F. In number 5, we're looking for a 0-degree polynomial. And that would mean that we're looking at talking about a polynomial where the degree was 0. Now we know that that also means that that value is 1. So when a number is put in front of that polynomial, basically it just comes out to be that number times 1. So as we look at the polynomials that we can consider that are left, we've got numbers in part G and in part J. All right. Going back to G, if I were to write this as 8 times x to the 0, that's also equal to 8. So we've got an answer to number 5 that's going to match with part G. Every constant polynomial has a degree of 0, except for the number 0 itself. We don't consider the number 0, which we see in part J. We don't consider that polynomial to have any degree. That's the polynomial off by itself. Every other number by itself, we call it a constant polynomial, and we would call that a degree 0. But the number 0 itself, we say that it's a polynomial with no degree. Alright, as we finish up here, the 4th degree polynomial that has a 3rd degree term, so we're going to be looking for the polynomial with the highest degree of 4, and what remains there, we only have that in part I. It does have a lead term that's a 4th degree, and it does have a 3rd degree term in there too, so that's part I. 4th degree polynomial, they do have a word for that one based on its the degree of it, and they call that a quartic. Alright. We have number 7, a trinomial with integer coefficients. So we're looking for the polynomials that are left with 3 terms, and that leaves us with C and B. And of course, as we look at the coefficients in C, we can see a fraction, so the trinomial that has integer coefficients is going to be in part B. Alright. Number 8, we're looking for a trinomial in x and y. So we got to look back and see which of the polynomials we have left in 3 terms, and that would be part C. We've got the 3 terms in part C, and they're using the variables x and y. So we would have an answer to part C there. And as we just talked about previously, back up there in number 5, the polynomial with no degree is going to be J. And the number 0 is the one that the only polynomial that would represent that one. Now in number 10, the last one, we're looking for a 4th degree binomial. So as we scroll back up and see what remains of the binomials, we see that we haven't used part A. And of the first term there, the degree of that term, we sum up the powers of the variables, and it does give us a 3 plus a 1 is a 4. So number 10 is going to match with part A. So, a lot of very common terms that come back. Number of terms, the 3 most common expressions refer to our trinomial and the binomial. And that one term, which was the monomial one. Degrees we can classify either by numbers, or as we went back into some of these, we talked about some of the special terms for those degrees as well. Alright, now we're going to move on back down and come to some calculations that are familiar to you by now, things that we've already used in some of the other types of problems we had performed. And what we want to focus on here is not that you don't know how to do these, but that you pay attention to the indicated operations, because that's where people tend to make most of their mistakes, is they just don't do the right calculation based on what's indicated in the problem. So number one, we've got two trinomials, and they're in parentheses, but they're separated by the sign, and that's going to indicate subtraction. So when you perform the subtraction, typically, or if it were an addition, typically what you could do is you can remove the parentheses. The first polynomial has nothing in front of it. There's nothing multiplied it, so it just stays as r squared minus 2r minus 5. The negative sign in front of this polynomial could also be the same thing as negative 1 times that polynomial. So as we come through, that negative 1 multiplies each of those terms. Now what people do is they tend to make the mistake of leaving the parenthesis around it, and then they act like they're going to multiply the polynomials. Once you bring that negative sign through, there's no multiplying of the other polynomial. You're going to combine those like terms. So as we bring the negative sign through, we're going to have a minus 3r squared, and then we get a plus 5r, and then a plus 7. So we don't leave the parentheses in, then we're focused on the fact that we are combining like terms. We come back and we put the terms together with the same degree. Here we have a minus 2r squared, and then we've got the r to the first powers, so we have a positive 3r. And then finally, we've got the plus 2. So the key with these things is not that they're hard and you don't know how to do them, but you do have to pay attention to the calculation involved and make sure you're doing the right calculation. In the second one, here's the common expression of doing a binomial times a binomial. There should be 4 multiplications here, and we've done this again quite often already in some of the work we've done in chapter 2. We're multiplying the 4x times the 3x for 12x to the second. And here we'll have 4x times a plus 4, a plus 16x. And then coming through with a negative 5, multiplying, we'll have a minus 15x. And then finally, last times last, there's a minus 20. The 2 multiplications in the middle give us like terms, and we finish up the expression x squared plus 1x minus 20. Right? And we don't go back and try to rewrite it in factored form, because what they wanted us to do was the multiplication. So we leave that as we combine those like terms, and we leave that trinomial as our answer. Alright, now we're on to some more multiplications on the back, and in number 3 we have a binomial times a trinomial. So you can write this out a little bit longer, or you can use the arrows. Basically, you've got to come through first, and you've got to multiply through by each of the 3 terms of the second polynomial by the 2x, and follow that up by multiplying by negative 3. So as we come through here with the first multiplication, we have the 2x times the 4x squared, and that gives us 8x to the third. The second multiplication gives us negative 10x to the second. And the third one gives us a positive 2x. As we come on back through and we're multiplying by the negative 3, we have 3 more multiplications to follow through with, and we end up with minus 12x squared. And then we have a positive 15x and a negative 3. And we're coming back and we're looking for like terms. There's only 1x to the third term. We've got a couple x squareds combining to a minus 22x squared. We've got 2x terms that total to a 17x, and we have a minus 3. Again, something that's fairly typical of some things you've already done this semester and you've been quite successful at. Alright, now in the third one, we're going to take a binomial expression and we're going to square it. As long as you remember to rewrite that binomial expression as a binomial time itself, you'll probably be doing it right. Mistakes are made when people look at it and they think they're going to do a shortcut or do it quickly and just do each of the terms to the second power and square it. So that does not come out to be 25y squared plus 9x squared. Alright, you do not get two terms when you square a binomial. You'll get a great big X on your paper and a great big no and get it marked wrong. So as we continue on and do it correctly, you will get the 4 multiplications that are necessary and eventually have it simplify to a trinomial. So 25y squared, we get the outer product as a negative 15xy. We continue through multiplying through by negative 3x. We'll get another negative at 15xy. And we will end up with a positive 9x squared. And we have the two middle terms that are like terms, and we do generate a trinomial for the answer, not a binomial. So don't make the freshman mistake and try to do it too quickly without the extra effort, and you should do it correctly. Alright, now we've got our last one, and this has a little bit of a combination here. You want to go back and rethink a little bit too about order of operations. You don't want to make the mistake we mentioned in number 3. You want to take those two expressions and write them out as though you're multiplying a binomial times itself. And keep that negative sign in between. And there's a second binomial also in there being squared. Alright, now we're going to keep the two parts of our answer separate. This first part here, we're going to keep the answer grouped separately from the second part, because the second part's important. As we get the answers to the second product, we've got to subtract each of those terms. So as we come through and we square the first binomial, we'll have 16x squared, we'll have a 20x, and a 20x, and a 25. And the second binomial will give us 4x squared, a minus 6x, a minus 6x, and a plus 9. And now if we think all the way back to the first problem, it's a difference of two polynomials. So there's 6x squared plus 40x plus 25. That's going to subtract 4x squared minus 12x plus 9. And as we come through to finish it, we do not have to do anything different to the first polynomial. It can come out of the parentheses. The second one, the same as if we were multiplying through by a negative 1, so all of these signs are going to change. It's going to be a negative 4x squared and become a positive 12x and a negative 9. And then we can finally come back and put the like terms together, or a 12x squared and a positive 52x. And the constants we put together is a positive 16. Alright, so nothing too difficult in this section. Do watch out and be aware of the calculations that you're doing and do the correct one, and you should be fine. So you are ready to move on to day 4 of your homework tomorrow. Should be a relatively quick and easy assignment as long as you're careful.